you go. So I think at least everyone in this room has a shared, what's the word I'm looking for? Interest to learning how to code. So welcome everybody. Thank you for joining us for episode 3 of the coding series. Today, the theme is building smooth apps. Although in order to appreciate what it means to build a smooth application, we're going to talk about, let's say, topics surrounding the theme of today. And for those who want to learn how to code, towards the end, we will talk about some learning strategies for learning to build applications, build smooth applications on your own. Let's jump into today's agenda. First, it's always important that we have clarity about our definitions. We'll ask what is an app, what does it really mean, what is an app exactly. We'll define that, and then once we know what we're talking about when we say app, we'll then talk about the key components. Okay? If you're someone who wants to build an application, you must understand the scope of work. Okay? Because it's not just about learning a programming language, but you must understand the key components that your application must have. Then we'll talk about the app environment. As you know, there are all kinds of applications, mobile application, desktop application. And we will talk about the different environments, meaning the different platforms. Okay, so environment, platform, we will use this to mean the same thing. Of course, we talk about building smooth applications, applications that are meant to be in the market, where people pay to use a service. Okay, it has customers, and we want to, we want to have the best. We want to create the best experience for our users, but we need to know what it means to have a smooth application, fast application, good application, which is why we'll talk about performance metrics. And then getting started. How do you go about producing such an application? The technical skills you need, where should you start, and so on. And as usual, if you have any questions, we'll answer them towards the end. Let's begin with the definition of an application. And like before, I invite you to define what it means to be, what an application is. What is an application? Again, one word, 2 words, 3 words. Give me your definition. What is an application? What comes to your mind when you see or hear this word? What's an application?
It's a system, program, system that we use.
It's a program that we use, a system that we use. Yeah, that's a good one. How about you? What comes to your mind?
Program that helps a customer.
Program that helps a customer. A program that is used. A user program. How about you, sir?
Application, I think it's a systematic or a pre-programmatic interface that talks between humans and the machine to make it work.
An interface. Interface is a good one. Interface. An interface. How would you define application?
I think it's simplified user interface to achieve some predefined task.
Okay, so programmed interface to enhance the user's experience. I paraphrase what you said, but I hope I. And how would you define?
I agree with that.
Okay, so it seems. Okay, so some interface, something with which the user can interact that will help them get what they want, get a service, get a product. It's a very good definition. Do you remember now? If this is your first time attending this, we had this slide back in episode 1, where we had to establish these 2 terms: program and process. It's very easy. A program is a file in which you've written a programming language, as you can see the picture. Code written in there. You have a Java, C++ file, you have a Java file, you have a Python file, anything file within a file extension, we call that a program. And when you run that file, or if it's an executable or a DMG file, when you double click that file, you turn that program into what? A process. Okay, in other words, you read the contents of this file from the computer's storage, and you bring it into the computer CPU, and from there into the computer's memory. This memory is something we'll talk about very soon. So let me give you a quick definition, a very basic definition. An application is a group of processes working in concert. An application is a collection of programs. And these programs do different things. It's just like a company. You know how companies have different employees, every employee has a specific role? That's what an application is. The user interface is one part of it, but so is saving, reading, and writing to the database. You said you're a solutions architect. Load balancing, right? Managing traffic that is coming into this application, application. There's a program for that. There is a program to send and receive or send notifications. You know, if someone sends you a text, part of that application is to give you like a notification on top of your phone. There's a program for that. This is what I mean. An application, okay, is a group of programs working together to, you know, facilitate that service for the end user. Of course, the first thing that comes to mind when we hear the word app is the user interface, but that's just one component. And we'll talk about the 4 key components very shortly. You did recognize it. Now we did see this. I'm not gonna go into detail about this, but this is from our previous episode. I'm just gonna show you this to you because if you want to build an application, right? If you want to have an application in 2021, okay, that group of programs we talked about, right? Those programs need to complete, or those, you know, an application that customers would now would find acceptable, must be able to fulfill a number of roles. Let me actually skip this. Well, basically, if you remember from the previous episode, you know, we talked about how we have one service. We call it, if you go to AWS or Azure, we have these things called cloud computing services. Okay, these are programs running in the cloud. Remember cloud computing? We have a program for storing pictures and videos, right? That's the cloud from that, the CDN. We talked about how we have different types of programming language, and if you want to run an application, you must choose the appropriate operating system. Anyway, we'll come back to this slide, but let me first address the key components. Now, these are just terms, but I will elaborate what these terms are. Now, these are the 4 components that go into an application. These terms are borrowed from Android. When you want to build an Android application, different aspects of your application will fall into either one of these categories. So what are these categories for? Let's break it down here. First, we have activities. We have a category called activities. The activities refers to mainly the user interface. The buttons, the checkboxes, the radios, the pictures, sliders, anything that the user can tap, drag around, that will fall into the categories. Different screens in your application. The home page, the main page, the settings page, the profile page, that falls into the category activities. Okay? When people say app, this is the first thing that comes to mind. But there's more. Services. These are programs that are running, but they're not visible to the user. You don't see them. What are the tasks? For example, let's use Gmail as an example. Let's look at the different components. Everyone knows what Gmail is. Let's divide Gmail into these 4 components. The first one, obviously, is the Gmail interface. You know, you have your inbox. And that you have this button where you click it and you can compose an email. You can make the text bold, you can make the text italic, you can attach files, right? These things would fall into activities. But what are services? What happens when you click on the send button? That email that you composed must somehow make its way to the recipient. This application must be able to do or make HTTP requests. Again, this is something we talked about in the previous episode, sending and receiving HTTP requests. A program there's a program that is running at the whole time to make it possible for you to send these messages. What happens when someone sends you a message? This program is running in the background so that if an email is sent to you, you will see it in the UI. Content providers. Content providers is some program that allows you to host files. Let's say you want to attach a file from Google Drive. That is a content provider. Or you attach a file from your computer. The content provider in this case is the browser, because when you attach a file, you want to send your customer a PDF, the invoice. So you click on attach file, and then you browse your computer. When you choose that PDF, you first give it to the browser. The browser has hold of that file, and then it's the browser that's the content provider. It's the browser who's giving you a copy of the PDF. Okay. If this were, for example, a social media application, and let's say Instagram, you're scrolling through your friends. You want to add a new friend or someone upset, you want to unfriend them. When you're scrolling through your list of friends, you're pulling information from the database. The database could be a SQL database, it could be from Oracle, it could be from MongoDB, whatever. But that's an example of a content provider. Broadcast receiver. Every application has this. What happens when someone sends you a WhatsApp text or sends you an email and you don't see it on your phone? You hear a sound. And then when you unlock your screen, you see a notification bar. There's a program for that as well. That's called a broadcast receiver. Okay? So your component, your application has a group of programs, and they all fall into either one of these categories. So when you want to learn a programming language and you want to build an application, the programming language you choose must be able to facilitate these. And you must be aware of this. You must understand the scope of your the scope of the application. Let's continue. Now, the app environment. We will talk about let's say the 4 main layers of the computer, because this will inform you. This will help you decide what is the appropriate platform to deploy an application, and from there, what will be the appropriate type of programming language. Remember, we have a large selection of programming languages, and it's overwhelming. Should I learn this one? Someone told me this is the best programming language. Another person told me that's the best programming language. Well, let's first let's come to this fundamental step here. This main step. Your computer has 4 layers. Okay. For us, or for you, the app developer, the top 3 is mainly important. Ideally, the more you know about all of them, the better, but mainly the first 3. Why? The 4th layer, that's the computer architecture, that's the hardware, the CPU, the bare metal, the cables, the physical part. Right on top of that, we have the operating system layer. Windows, Macintosh, Android, Java, iOS, right? Ubuntu. But this operating system, this software that runs on your computer, is itself an environment. It's a place where applications can run, here in the application layer. What are some applications that run inside the operating system? Microsoft Excel, Google Chrome, Firefox, Zoom, right? When you go to your start menu and you search for an application, you click on that, that is an application that's running in the operating system. But then we have a special type of application inside the application layer that it is also a host or an environment for another application. You know what that platform is, or what that application is? It's the web browser. Okay, the web browsers, these apps, they're apps themselves, but they allow you to run apps within themselves. So we come to the web layer. Okay.
So the web app, it's an application.
It's an application.
It's an application, but with added access to it.
With added access?
Access, so that you can login through web.
Exactly. Do you remember those 4 components? What were they again? Activity, services, content, broadcast. All 4, oops, I went too far ahead. All 4 exist in the web layer, in the application layer, and certainly in the operating system layer. Now, which programming language you choose to go with, what type of application you choose to produce depends on where the application is meant to run. Okay, the first question is what problem are you trying to solve? You have a great business idea, you have a great service. Okay, what is the best place for that application to exist? It depends on how demanding this application is. There's a number of factors, but let's begin with a couple. Number 1, how much computation power does it need? If you're talking about a software like Photoshop is very computation intensive. It uses a lot of CPU, a lot of RAM. It even uses a lot of permanent storage because it needs to cache files. So this Photoshop, because of its size and because of how demanding it is, it has to be close to the computer architecture. It has to be close to the physical components of the computer. So what is the best environment for it to run? On the operating system. But then you have applications like the calculator, that simple calculator. That calculator is simple. It is not computation intensive. So it is not necessary to leave it in the application layer. It is something that can live in the web layer. Let me take a step back and say it another way. There are 2 things to understand. First of all, you want to, as much as possible, put your applications here in the web layer. Why is this? If you're an application, if you're a company like Adobe, who produces applications like Photoshop or Adobe Premiere or any of their their videography or photography software, it is necessary that you build an application in this layer, which is close to the operating system and close to computer architecture, because of just how demanding these applications are. The problem with this is, yes, these applications are super. We have a huge market. The problem is they're also expensive. They're expensive to maintain. Why? We have 2 main operating systems, Windows and Macintosh. But even within Windows, we have different versions of operating systems. And the same thing with the Macintosh. Every time this company, Adobe, wants to release a new update to their Photoshop software, they must make sure it runs on this version of Windows, on this version of Windows, this version of Windows, and it works on this version of Mac. So you can see they have to, for a small change, you have to repeat themselves again and again and again. It's a very expensive thing. Number 2, another problem. If the user wants the application, they want it, they like it. They must, it costs them something, right? It costs them physical space. Like when you download an application, it's going to take up space on your computer, which means you're left with less space. Now ask yourself this: is this expense worth it? Like, is Photoshop or Adobe Premiere so? Is it valuable enough that the user is willing to pay that kind of expense? Yes or no? If it's yes, then why not build an application for the application layer, which runs on the operating system? Now, of course, maybe I should have added a slide for this. If they could have their way, if Adobe could have its way, if MATLAB, if you know what MATLAB is a software for modeling mathematical phenomena, earthquakes, automotive mechanical parts, airplanes. Again, because you're working with graphics, it's very computation intensive. So MATLAB, Photoshop, video game. Oh my goodness, video game is a humongous industry. Video games, right? Everyone loves video games. If they all could have their way, they would put their application here in the web layer. In fact, let me tell you that they all are trying very hard to move up from the application layer into the web layer. Why? If you're able to put an application in the web layer, those costs we talked about are eliminated. No longer will the user have to download something to their computer. These applications are getting bigger and bigger by the day. 5 gigs, 10 gigs. If you talk about video games, they're even bigger still. So these users have to wait a long time for this application to upgrade. Furthermore, not everyone can afford a premium laptop. So some people are left out. But when you move into the web or the cloud, remember the word cloud just means internet. The user no longer has to download anything. It takes up no space on the computer. It's not going to slow down their computer. If there's a maintenance, here's the best part. If the software vendor wants to maintain something, they just update it once. Because now you don't have to build the application on multiple operating systems. You have one operating system, which is on the cloud. And if you update it once, it will run for all the users on the web. Now that would be the ideal scenario. So why haven't they done this? Well, they kind of are. But if we go back, let's say 5 years ago, 10 decades ago, this wouldn't be possible because web browsers were limited in terms of how much CPU and RAM they could use. They were limited. But we no longer at that point anymore. If you go back to the 90s, when the web browser were first invented, they had one purpose. Web browsers were meant to show you simple documents, just text and images. That was their origin purpose. But computers evolved, software evolved, to the extent that now you can run applications like Photoshop, like MATLAB, like AutoCAD. You can watch 4K videos. You can play really GPU, CPU intensive games all in the web browser. You type in a URL, something.com, log in, and it's there. There's something called Amazon Workspace. Does anyone know Amazon Workspace? Virtual desktop. You can click how much computation power you want. 32 gigs of memory. Hundreds and hundreds of RAM. I'm not talking about storage, RAM. As much as CPU you want. Any laptop, any operating system you want on the cloud. So you can buy yourself like a tablet, but you can be working with the most powerful machine ever on the cloud. You don't have to buy the hardware. You don't have to. It's just so much affordable. By just logging it, as long as you have internet connection, you have all the computation power you need. So why have I gone on length about this? Because you want to focus your efforts not on the operating system layer, not on the application layer, the web layer. Because if you understand web technology, okay, the number of things you have to learn will drastically decrease. Okay, so for example, if you want to build an application on Windows, you have to understand how Windows works. You have to understand C++ because that's the only way you can get an application to run on Windows. And C++ is a humongous programming language. We talked about programming constructs in episode 1, but when it comes to C++, you have a lot more programming constructs. There's so much you have to do as a developer if you're working on these two layers. But in the web, the number of things you know are drastically diminished. And what's more, if you develop on these two layers, like I said, you have to repeat yourself. If you want to build a mobile application for your customers, like you're the next Clubhouse, you build it once on the iPhone and you build it again for Android. If you remember when Clubhouse first came, it was exclusive to iPhone users because they weren't able to as quickly develop the same for Android. So they were losing out on opportunity. If they were on the web platform, everyone could access it. Whether they had a cheap laptop, doesn't matter. In other words, so let me just make a simple statement. This is the platform to be on. Let me also just make this one more point before we move on. I think it was around 2013 or 14, several years ago. I attended a workshop. It was put together by Google. And they were showing the reports of the Google App Store. They said, do you know what's the average applications, the average number of applications that are installed from the Play Store? Does anyone know? Try to go back to 2013-14. What was the average number of apps installed? How many apps do we have on the App Store? Hundreds of thousands? What is the average number of apps that the user installs per month? No. What is the average number of apps a person installs per month? The answer is 0. The average app installment in the App Store per month is 0. That number hasn't changed much since then. Why is that? Well, if you're maybe a big company like YouTube, Facebook, Instagram, WhatsApp, these small number of application vendors, that doesn't apply to you. Everyone else, they won't even sees you because it's cumbersome. Even if you have a great idea, how are they going to find you? How are people going to find your application? You have to go to the App Store or the same thing on the Play Store, right? They all look the same. Like there's no way an application can stand out. They all have these small icons, brief description. And even if you do find the application you like, you have to click install, you have to wait for the installation to complete. And even after you've installed it, you have to regularly keep on updating it. People do not want this. That process is cumbersome. And then there's security concerns. People are now more aware. They do not like to grant permissions to you, the software provider, because they'll think, all right, you'll have access to my contacts, you'll have access to my camera, you'll be listening to me when I'm sleeping. They avoid it as much as they can. Those concerns are eliminated once you move to the web platform. So in fact, Google was saying we're moving towards something called progressive web apps. Anyone heard of these, PWAs? Progressive web apps are applications that are built with web technology, HTML, CSS, JavaScript, but the user experience is the same as that of a native application. Let me say that again. You know how web applications work, right? You've seen websites. They're not that great, most of them. But the trend is moving towards what we call PWS, applications that are built with web technology, but they're as good, if not better, than native applications. You ever know Slack? Everyone uses Slack, right? Slack is an app you install that you have to download and install. Actually, you don't have to, but you can. Slack is an application that is built with web technology. The UI that you've seen is HTML and CSS and JavaScript. It's a powerful application. It's very smooth. It's built with web technology. Web technology is something an individual can learn. Let's continue. So I hope you agree, and I want you, and I don't want you to take my word. I want you to do your own research. But if you want to choose a programming language, you want to learn to program, you want to become an app developer, again, you want to be informed by the appropriate layer. I'm telling you that this is the first and foremost layer. This is the ideal one. And the trend is moving towards the cloud. I mean, Amazon is investing so much in the cloud. Okay? So, but I want you to do your research. Look at the number of companies that are investing in PWAs or are migrating their applications from different they're migrating from different programming languages that they used to have to one programming language. That one programming language that is the king in the web layer, Can you spot it? Does anyone know? That programming language is JavaScript. Okay, you can use PHP to build applications. Part of the application, actually. If you want to build the UI, you need another programming language. You can use C# to build applications. C++, of course. I mean, that goes without saying. Kotlin. And there are a lot more. Python also. Java 2. But when it comes to the web layer, JavaScript is the main one. Primarily, the reason for this is because JavaScript was and still is the only programming language that web browsers understand. If you want to build a UI, you want to build a web application in the web layer, like Slack. If you want to build your UI, you must program it with a programming language. Okay? If you want to build a UI on Windows or on Mac, you have different selection of programming language. You can choose one or the other. But when it comes to the browser, it's not that JavaScript is the best. JavaScript is the only option you have. So if you want to be like Netflix or Slack or YouTube or Amazon, and you want to build applications on the web to have the most impact, your only option is JavaScript. Not that it's the best one, it's the only option. Now, JavaScript started here. It was meant for that layer, and it still is. But then because of something we call Node.js, anyone ever heard of Node.js? Node.js made it possible for let me take a step back. So we do understand that the only platform that understands JavaScript is the web browser. And when you type a JavaScript code in the web browser, all web browsers understand the code. They can convert it to binary. If you put JavaScript anywhere else, it's not going to work. Node.js is an application, it's a tiny application that you install on your computer that it converts JavaScript to binary. Because Node.js is able to convert JavaScript to binary, you're able to run JavaScript on any of these layers. I do not know how if you understood this part or not, but the implication is humongous. Because if you can write, if you learn one programming language, and you're able to run that programming language on any of these layers, what does that mean? That means you're not just a web developer. You're a web developer, you're a mobile developer, you're a desktop app developer, you're a robot developer, you're an IoT developer. Did you know that JavaScript can be used to program robots and IoT devices, mobile applications? You learn web technology, but because of JavaScript and Node.js, you effectively become a cross-platform developer. Any platform that you want to develop, small, big, you can do it. One program language.
Why specifically Node.js can work on multiple platforms? What's special?
Node.js has two parts. The main part is the Google Chrome engine. We know why Google Chrome is so popular, right? Because of how fast it is. What JavaScript does, usually when you want to convert, if you want to run a program on a computer, it goes through different stages before it becomes binary, right? Machines, like these they only understand binary. So if you want to go from a programming language which we humans understand to something the computer understands, you must go through different stages of translation. Okay? What Chrome does that makes it so fast is it eliminates many of these stages. So instead of going through 6 stages, it goes through 3 stages. That is why applications are so fast, snappy. Node.js took that part of the Chromium engine and said, we just want that part. We just want to be able to go from JavaScript to binary more quickly. It's a small application. But this ability to go from JavaScript to binary very quickly allow JavaScript to be used for any platform. This is why Microsoft, who created C# and VB.NET and the .NET suite of technologies, they themselves are moving to JavaScript. They are leaving their own programming language behind and adopting JavaScript. They said, we cannot come close to this. This is it. Everyone's moving towards this. They too are moving towards it. Google also. Google has their own programming language. They're moving towards JavaScript. In fact, they created a programming language called Flutter, which is very much like JavaScript. So if you invest your time into this, you are on the right track. Let me continue with this. Let's briefly talk about performance metrics, and like I promised, yes.
Sorry.
Yeah.
So Node.js has its own text programming language,
No. Node.js is a
or it's only a platform converter?
it's just it's a converter. That's all it is.
So is it-
It has a few modules for web service because it was meant to be a replacement for Nginx and Apache. You know, Nginx and Apache are multi-threaded. Node.js wants to be single-threaded. Okay, so the guy who created it had a great idea for making web servers faster, but he needed a program language to make it possible. He first thought Ruby, but Ruby was already meant for web service, so it was a big language. He wanted to find a program language that was small enough that it could just, convert. So he said, you know what, let's go with JavaScript. This combination, these two worlds meeting together, just changed web technology altogether. All right, so let's talk about performance metrics very quickly. Now, no matter which programming language you choose to go with, no matter what type of application you're trying to create, big, small, whatever, these are the 4 things your application must, these are the 4 conditions it must satisfy. First of all, it has accessibility, meaning the user should not struggle to find what they want. Interface should be simple. Everything should be within reach. You go to some websites, you can't find out the logout button, or a banner opens up and you can't find the close button. That is not an accessible website. The font is too small. The button is, I don't know, weird. Or you have to search up and down to find what it's for. You want the interface to be friendly, simple, accessible. Okay, now this is mostly in the domain of UX and UI design. Okay, but if you're not a designer, you can follow the lead. You can follow what the others are doing. If you, for example, look at Instagram, if you look at YouTube, the designs are simple, but they work. Speed. This goes without saying. People do not like to wait. If the website is slow, if the pictures take too long to load, if the videos take too long to load, if they click on something but it takes forever to load, that's going to kill. That's going to kill their interest. Availability. Let's say you have a great interface, the application is fast, but you have defects, you have bugs. You click on login, you log in quickly, your profile picture shows up, but then I don't know. When you click on save, the save button doesn't work. There's a bug somewhere. Bugs are something, defects in general, are something you must always address. It's better to have fewer features, but working features, than have all the features, but that are defective. Okay? And then memory. This is a big one. One of the downsides of making applications fast, or one of the ways that you can make an application fast, is to download everything or put as much as you can on the user's storage, right? Because the files, the pictures, the videos are already on the computer, on the physical computer. You don't have to download them again. The user doesn't have to wait. The problem is, it takes up a lot of memory. In fact, if you take Google Chrome, for example, a lot of people are now abandoning Google Chrome because of this reason. It used to be fast. I mean, the reason it was so popular was because it was fast. But Google Chrome has started to consume a lot of memory. This is what do you call it? The pros and cons are starting to balance out.
Firefox.
I personally have abandoned Chrome. After many years, I've now switched to Firefox because Chrome was taking too much of my memory. It was starting to freeze my computer. So you cannot compromise any of these. It's better to have a simple application, few interfaces, few features, but you have 1, 2, 3, 4. Okay. Now getting started. So this is a loaded diagram, but I'll break it down for you. This is for you if you want to build an application and you don't know where to start. Now, again, my word of advice is to begin with JavaScript. I'll tell you why JavaScript. I'll give you more reasons to learn JavaScript. But here's how you want to approach it. You remember those 4 components we talked about? Those 4 components every application must have: activities. What was the other one? Services. What's that? Broadcasters, right? All 4. That's a lot of work for a single person to do. Okay. In fact, if you have a SaaS in mind, like an actual software product in mind, ideally you should have 5 members on your team. In a separate workshop, I talked about what these 5 people will do, but understand that is the standard. If you fall below the standard, you must be aware of that fact and try to improvise somehow. But if you want to build an actual product that is in the market, these 5 people will play a crucial role. So what can you do if you're all on your own? Look at this spectrum. You have managed, unmanaged. What does it mean to be a managed application or managed service? If we go to the very top of this chart, when we say something is managed, that means you do not do any code. You don't write a line of code. For example, what are examples of managed applications? Gmail. If you want to send an email, do you write an email server? No. Email program? No. You just go to Gmail or Yahoo or whatever, log in with your account, compose your email, hit send. You're done. At the opposite, or the other end of the spectrum, you have unmanaged. That's where you have to do all of the work. Like there's no SaaS, and you have to do all of the work. You have to buy the physical computers. You have to run the operating systems. Like you have to configure. You have to configure the software. Write the software on your own. Take care of the networking. Like all of the things you have to do on your own. There's no third party. So what you want to do is start here, and only go down when necessary. So there are, let's say you have a great business idea, you have a great product, okay? Let's say you want to sell shoes, you want to sell handmade bags. Many people sell bags on Instagram. You don't write a line of code, they just take nice pictures, okay? And Instagram gives you the ability to directly reach out to people and, make a sale. There are websites like Shopify. Shopify, you pay a subscription fee, you have a nice website, and everything an e-commerce website has its own. You don't write a line of code. Now there will be cases where you cannot find anything on the internet that meets your needs, so you need to start customizing. You need some level of control. That is where you start to go down the spectrum. Not all the way down. That's not something you want to do alone. Maybe somewhere in this vicinity. So you start to pick up programming language. Okay, any of these. But then once you build this program, you need to deploy this program somewhere, right? Let's say you want to build a web application. This web application must be on the internet so people can start using it. How are you going to deploy this application? Where are you going to deploy this application? If you remember from episode 2, we talked about data centers. Data centers are not something you want to put together. But what you can do is give your application to a cloud vendor who do have those data centers, like Google Cloud and AWS and Microsoft Azure. You build your application and say, hey, I need this application to run on Ubuntu. These cloud vendors have those operating systems. They have the physical infrastructure to host your application. In other words, first start. I mean, this itself warrants another workshop, but start at the top, and only if you cannot find something that is ready-made, work your way down here. Okay, but if you're a complete beginner, this can be overwhelming. I suggest you begin here. Okay. Yes, the only reason I have this slide in here is because it depends on what this is generally speaking. We have data science and we have computer science. If you want to build web applications, JavaScript is the way to go. If you're a data scientist, if you want to work with data, Python is a program you want to go with. Now, both of these have a lot of things in common. Number one, they're both very easy to learn. And I said this before, like in our own coding bootcamp, we teach this in the first week. Okay, not everything, but the building blocks we teach in the first week. But if you learn JavaScript and you want to experiment with Python, they're so similar that you can pick it up in less than half the time. So if you spend a month, 2 months learning JavaScript, it's going to take you a few weeks to learn Python. That's worst case. And vice versa. If you learn Python, it's not going to take you as much time to learn JavaScript. And yeah, so like I promised, I want to leave the remaining 5 minutes. Let's make it 10 minutes to answer your questions. So I'm sure now that we've gone through all of these slides, you most certainly have questions, and I will try to answer them now. So does anyone want to begin? Any questions come to mind?
Node.js, is it specific for the JavaScript?
It is exclusive JavaScript, yeah. But again, it's not a programming language. It's not a programming language. It is something, it's an application that you download. It's an executable or a DMG file. You install it, and that allows you to write JavaScript programs for the web or the operating system, or like I said, you can use it to, if you install Node.js, for example, on a robot, you can program the robot with JavaScript. So it's not something you have to learn. As long as in your JavaScript, you have the power to create applications on any given platform. If there's an electronic device and you can run software on it, chances are you can program it with JavaScript.
It's like a translator.
It's a translator. That's the best way to put it. It's a translator. Every programming language has a translator. C++ has GNU. Python has the Python interpreter. If you want to be a Python developer, the first thing you must do is go to Python, download the interpreter. The word interpret, it's like translate. Java has JVM. Okay? Now, before Node.js, for JavaScript, the only interpreter was the browser. But now we have Node.js. So because Python has the Python interpreter, you can use Python to build cross-platform applications. Because C++ has GNU, you can use C++ to program different applications. Now, because JavaScript has Node.js, which is the equivalent of GNU for C++ or the interpreter for Python, you can use JavaScript to build applications on any platform. That's it. That's all there is to it.
Okay, so what is the development life cycle? So, because I hear it a lot.
The development life cycle. The development life cycle is, you see, a software is something that you must maintain regularly. Moreover, when you are building a product, initially it's not going to have all the features that you have. You may think about features after it's even in the market. Go, hey, we can. Why don't we do this for application? In other words, this application that you create.
We create the 4 main key components we talked about. Right?
Do you know the word MVP, minimal viable product? Minimal viable product is, let's say you have a long list of things. It's a prototype. You sit down with your colleagues and you say, you know what? The market now needs this kind of application. It must be able to do this, and the list is like very long. Realistically, you can complete 4 or 5 of those features, unless you have an investor who brings you all the developers. You won't be able to complete all of this one. If you're a sole developer, okay, there are 2 things you can do. You can either try to finish as much as you can, create a prototype, or spend 2-3 years on the application before it ever makes it to the market. Step 2, the second route, is what kills many startups. They wait too long. They get too ambitious. They stretch themselves thin. The app never makes its way to the market. So this, if I can put it simply, this application is going to evolve. It's going to keep changing and changing over time.
My mind works in a stepwise way. So
Exactly.
It's a prototype. And then after a prototype, I'm going to innovate like some certain features that I'm going to.
No, the software lifecycle is this evolution.
Then I will go to the 4
It's
key
just-
components because I'm trying to connect things.
Right.
Together. Then I will go to the 4 key components that creates the application, right? So I'm going to utilize the features and services as an example.
But no, I want to, because I want to put, we need to be clear about this. So these are the 4 components, right?
Yes.
If you have a prototype, you will have 4 of these, but this will be very simplified. For example, instead of having 10 screens, you will have 2 screens.
Agreed.
And in this life cycle, you will start to have more activities, more services, more content, more broadcasting.
Okay.
So you will go from, if you remember, like Facebook in the early days,
Yeah.
to what it is now, or Instagram, what it was in the early days, to what it is now. That's what we want to. And software is something you must keep on maintaining, adding features, adding features, adding features. Browsers will be updated, new computer architecture will arrive, so your application must be able to run on these updated technologies.
So what is the problem?
What's the
Software bug.
software bug? I use the umbrella term defect because there are different things that cause a software to be defective. But a software defect is
You mean like a missing syntax or?
it could be a missing syntax. It could be because you have third-party library that is not compatible with this library. You have a piece of, or you have a module that doesn't work on the latest operating system. You know how people will tell you do not always update your Mac operating system because the application will stop working? That's the reason. That's a defect because there's a defect with the latest release. Okay. Any other questions?
So let's say for the web app and the norm standard websites.
Right.
So are there major differences?
Sorry, can you repeat the question?
Between the standard websites and the web apps.
Right.
Like for example, Microsoft, you run it on the web, but you can consider web app.
Correct. Good question. The difference is a plain website, plain HTML, CSS is it's not even fair to put them in this category. Like a plain website just has number one of the four. It's basically a paper, but made digital. That's what a website is, a web page is. But we've taken, we're now using HTML, CSS not to create simple documents that are digital papers, but to recreate UI components that run on the web. I don't know if that gets the idea across. In other words, whatever you can find in the Play Store and the App Store, we have the technology to replicate that in the browser. If we can do full, with JavaScript, it's just JavaScript.
Not HTML, CSS.
You need HTML, CSS, but there's something called React. You may have heard of React. What React does is it converts JavaScript to HTML and CSS. You see, if you want to build a button, with HTML and CSS, you have to do a lot of HTML and CSS. Moreover, that button will not be interactive because HTML is only for presentation. If you want to make the button interactive, meaning when you click it, it does something. For example, it runs a service or loads of content. HTML and CSS will not be able to produce these. You need a programming language to do that. That programming language is JavaScript.
So within HTML, CSS, you add plugins. These plugins you can use JavaScript. Make it
Not quite. Let me put it another way. You see, anything you see in a web page, anything that you see on the web page is made of HTML and CSS. HTML controls the layout. If you want to put your nav bar here, your footer here, your sidebar here, HTML is how you tell the browser how to do it. HTML is like a manual for the browser. Put my button here, put my picture there, put my video there. CSS is how you control the appearance. I want this color, I want this font, I want to position 5 margins here, give it a shadow, okay? So it's the design. But if you want to control these components, these UI elements, the only way you can control them is with the JavaScript programming language. So if you want to tell the browser, hey browser, when the user clicks on the button, send this message, the only way you can tell the browser to do this is to write the instruction in JavaScript.
It's like the treatment rules, the actions.
Precisely. JavaScript is what allows you to gain control of the things on the web page.
But HTML has this functionality. Right?
HTML doesn't have this functionality.
If you click on this link, it will open another web page.
That's okay, maybe we can, that's one exception, but that's a very limited capability. Very.
But opening Microsoft Teams as an example.
Exactly. Microsoft Teams where you can drag, like resize the sidebar, or when you click on the button and this drop down opens up, or
this is a completely opening a video application, cloud video application.
that's JavaScript. You can only,
It's JavaScript.
exactly.
It's completely
You know the YouTube video player? The YouTube video player, the frame is HTML. The play button is HTML. The scrubber, the thing you drag around, is HTML. The full screen button is HTML. If you take out JavaScript, it's just a wireframe. Or if you click on the play, it's not going to do anything. If you click on full screen, it's not going to do anything. If you want to make the button do something, if you want to make the full screen button do something, if you want to be able to drag and drop, drag around the scrubber, it's not going to do anything. But you can use JavaScript to tell the browser, hey, when the user holds this and drags it around, this is what I want you to do.
So if there's a bug within action,
It's JavaScript. The problem isn't JavaScript.
Quality JavaScript.
Exactly. So learning resources, if, I don't know if you have any questions, but let me tell you where to begin. Now, I touched this on this at the very beginning before some of you joined up, but let me repeat this again. You know that there are a lot of learning resources, right? Udemy, Coursera, edX, plenty. My number one learning resource, this is something I started my career with this platform. It's lynda.com. Lynda.com is now known as LinkedIn Learning. They were bought by LinkedIn, now they rebranded to LinkedIn Learning. So why do I say LinkedIn Learning over edX, Coursera, and all of the others? If you've taken a course on Coursera or edX, or if you've seen any video on YouTube, everyone has their own way of teaching things. And the problem is, so you open a video and you hope, all right, so I want to learn some HTML. You open a video that says, learn HTML in 30 minutes, learn HTML in 1 minute, or it's like a playlist. You have to go through the whole thing, or at least you have to go halfway through the thing before you know if this is right or not, right? There is no quality control. Even with courses like edX and Coursera, which are university taught courses, there is no quality control. It's up to the professor. And if the professor, for some reason, made assumptions about you, and they left out some information detail, you're stuck. Your option is to either struggle or find another course. Not the case with LinkedIn Learning. With LinkedIn Learning, no matter what kind of course they're teaching, every single course must follow a certain template. If you've watched videos on LinkedIn Learning, you'll find they all have the same look and feel, and the breakdown is the same. That is the policy of LinkedIn Learning. Lynda, to be particular. Lynda has a policy that if you want to make tutorials on our platform, first of all, we must record the video. Like you have to actually come to our recording office. We film you with our audio equipment, and you must follow this template. In other words,
It's a full content. Because what I see always is, it's like an overview, like.
no, there are some that go into depth. You have courses that are 1 hour long. You have those that will take you weeks to complete. For example, there is a series called DevOps. It goes from the very basics to the deepest, most advanced topics. Meaning you have to spend like a couple of months to complete it. One thing that they all have in common is consistency. So if you want to learn this programming language, whatever skill you want to learn in a time frame, like you say, in 2 weeks, I want to learn this. Your best bet is to go with LinkedIn Learning. Of course, it's a paid service, but they give you a 30-month trial. I strongly recommend start with that. Go with the trial. If you're not happy with what you're getting, you can go back to your old habits, YouTube and Google. I also talked about learning theoretical topics, right? This topic came up.
What's your opinion about Udacity?
Udacity, again, that's another website. No, Udemy, I think is worse than Udacity. Udacity is like Coursera, isn't it?
Udacity is specifically for, like the programming. And
yes, but again,
not broad like Udemy. It's heavily concentrated.
Udemy is definitely is a problem because there is no quality control.
No.
And so I don't recommend it. You could be lucky and find someone who really knows their stuff, but it's like flipping a coin. and you're wasting your time as well. Even if it's free or it's cheap, you're wasting your time. Udacity is like, suffers from the same symptoms that edX and Coursera. No consistency. Yes, they're taught by university faculty, but we go back to the problem we have with edX and Coursera. No consistency. They may teach you A, B, C, D, but they may forget, or for some reason assume that you know G, H, I. And so you have to fill in those blanks yourself.
So LinkedIn Learning resolves this
For the most part, yes. For the most part, yes. Best part is you pay one subscription fee and you have access to the entirety of the library. Now that's for the practical aspects. So you know that when you were talking about any topic in computer science or data science, you have practical skills, you have theoretical skills. For practical skills, yeah, LinkedIn Learning, hands down. For theoretical skills, from experience, textbooks are better. Textbooks are better. And for technical topics, I advise you, whatever you do, don't use search engines. For technical, like if you want a theoretical understanding of something deep, do not use search engines. Search engines are worse than Udemy and Coursera for theoretical topics. We did this. We did this exercise in our coding bootcamp where we tried to show people the meaning of API.
This one I needed so much.
Well, I defined it. I defined in the episode. If you can go back and watch
in 2 or 1?
in episode 2,
2.
you definitely want to watch it. Now we're kind of going over time, but I hope you don't mind. You want me to show you something very quickly to show you why you don't want to use search engines? Let me show. Let's do a quick exercise.
What if they're like peer reviewed and you find
If it's peer reviewed, sure. If the blog is from, let's say, many faculty, many professors or experts have their own blog. If you find a nice blog, yeah, great, no problem. I'm not talking about the websites. I'm not saying websites are bad. I'm saying search engines are a problem. Let's do an exercise. Let me show you what I do in every coding bootcamp. What is an API, right? If you want to learn JavaScript, Node.js, this is what you do. What is Node.js? Let's switch to English. Let me show you something. Let's begin with the first search result. What does it say? API is what? Interface. Let's try to stick with one word. Interface. First search result says it's an interface. Let's move on to the second search result. What did it say? Software intermediary. So the first one said interface. The second one said software intermediary. So far, so good. This is just a copy of the other one. I mean, it's the same website. Let's go to set of functions. Interface, intermediary set of functions. Interface set of functions are two very different things. Anyway, let's continue. Software intermediary, that's the same website. Set of functions and procedures, and this website is called apifriends.com. Let's continue. They don't even tell you what this is. They just tell you most large companies have built APIs, whatever that means. Defines interactions between multiple software applications. I mean, this is even more convoluted than the one we've seen. So far, has anyone understood what the API means? I mean, if you attended the second episode, you do know. But so far, I don't think.
I know it from before that it connects microservices and it communicates with multiple microservices.
He hasn't been to episode 2. Okay, let's continue. Set of definitions and protocols. One said interface, another one's an intermediary. This one is saying set of definitions. Another one said set of functions. None of them agree with each other. This is the first search result. So this is what happens to you when you, by the way, none of them are correct. The only one that is correct, by the way, is redhat.com. Protocols. When we talked about rules for communicating, rules for how the host and client should talk to each other, that's what they're saying. That's the correct definition. If you did not know the correct definition, you would go with the first one. Or Wikipedia. This is why people struggle to learn. They open Wikipedia, they see the article, but this article takes you to 10 different pages. So you open this tab, this tab, this tab, this tab, and by the time you have 20 tabs open and you're nowhere near,
And you give up.
and you give up. You give up. You get frustrated and you say, you know what, man,
Change the topic.
forget application developer. I'll become I'll go into Bitcoin, or I'll become a. You change. So what is my recommendation? You want to. So the reason I say textbooks is because textbooks are written by experts. Person has a PhD. He's been teaching for 10, or he or she has been teaching for 5, 10, 15 years at a university. Their textbook is used in every university curriculum. Meaning this textbook, the information you find here, is as precise and accurate as it can get. So what I do is I go to a bookstore, Kinokuniya, for example. I find the textbook, I flip through it. I look at the end of the page, the index where they have all of the list of terms. If that book has the terms that I'm looking for, let's say API or Node.js, I flip through and I see if they explain it clearly. I buy that book. That book becomes my search engine. The next time I'm going to look up a technical term, I open the textbook, I go to the index, find the page, and that's where I look it up. Only for theoretical, the theory part. Because the answer that I get is the best possible answer that I can find. Now I go a bit further because I actually buy 3 textbooks for that topic. Because again, one author may define a topic this way, but they may leave out a detail, right? Because they assume you know what, they may assume you know the prerequisites. But the second and third textbooks will fill in the blanks. Okay. Yeah, so for theory, if you want to get into deep into computer science, textbooks. Okay. For practical skills, to learn how to code, to build an application, to do cloud compute, to build something, you can go with tutorials. And out of all of these tutorial providers, number 1 would be LinkedIn. I think that's all that comes to mind. I think for our 4th episode, we may do some coding. So if you want to get started with coding, we'll do that to some extent on our 4th episode. So yeah, maybe we can do that on our 4th episode. Well, yeah. Well, if you want to learn to do something, if you want the practical skills, ideally, yes, you bring it with you. Okay. Very well. I first of all, sorry for taking more than 1 hour to finish what I was about, this class. Hopefully you find it useful. By the way, if you have any questions after this coding series is over, or maybe after today's session, and you want to reach out to me, that's my email. I'll be happy to answer your questions if you have any. And with that, thank you very much for joining me, and enjoy your evening, of course. Bye-bye.